Get my feet locked.
Waves.
Mr. Karnstead, did you know that Mr. Harkins is a world champion server?
I did, as evidenced by the picture.
Pictures don't
Here.
lie.
Totally tubular.
You can believe it because it's on the internet.
Yep.
Truth.
So anyway, now before I even get started, this is the waves unit,
Yes.
and waves are not. We're not just talking about water waves here.
Nope, there's other kinds.
There are many, many kinds of
Lots.
waves, but the general definition for a wave is a disturbance that carries energy through matter or space. So either through something made of atoms or through space itself.
Cool.
Does that include solids?
It does include solids.
Liquids, gases?
Both of them, yeah.
Any kinds
All
of
three,
matter.
solids,
Look
liquids,
at
gases.
that.
Yep. Anyway, so at the bottom you see a little wave diagram. Now we're actually going to explain this, and then you're actually going to learn how to draw those. That's how any wave sort of
arts
looks
and
like.
crafts.
Not any wave, but
Yeah.
that's how a lot of waves look.
All right, so one of the biggest pieces and kind of one of the keyest ones is, I don't know if that's a word, but it is right now, is wavelength. And wavelength is simply defined as the distance from one point of wave to the same point on the next wave. So as long as you have two spots that are the same on a wave, like the top or the bottom, or even the middle, whatever you want to do, the measurement is just from one to the next.
So it can be any point on one wave to the same spot on another wave. The
Correct.
next one, right? And that's one length of a wave or
Yeah.
wavelength.
So how many
I'm
full
going
waves
to
are
illustrate
here?
this with the mouse. So one wave, and I'm sorry if I'm getting in the way of the camera, but one wave, if you follow my mouse, it goes up
Okay.
and then below that normal line and then back up. So this point to this point is actually not a wavelength. It is half a wavelength.
Half.
Okay,
Oh,
that makes
So
sense.
think of it this way. At this point, the line's going down, okay? If you start here, it goes up, then down, okay?
And then comes
Then you got to
back
wait
up.
until you get it to go down again until you consider that a wavelength. So one wavelength from here is right here.
So
That's
how
where
many-
some people
So
get
it's an up and
confused.
down
Up and down,
together as a
right?
complete
Yeah.
wave.
You have
That's
to
the
go
length of
completely
one
up and
wave.
down.
Okay.
So how many waves would you say are there at the moment then?
I would say there are
Complete waves, complete waves.
three complete
Three
waves.
complete.
Three complete.
Maybe a hair
Waves.
over,
I said
but
waves.
three complete.
Waves.
Waves.
All right.
You go one here. Sorry, I'm doing bad with the mouse. Two, and then three.
Gotcha. And that
Just like
extra
that.
little bit wouldn't count because it's
Not a complete
finished.
wave.
Yeah.
So let's take a look.
Very nice.
All right. Amplitude. Now we're starting to talk about terms, things that describe parts of the wave. Amplitude is really just how tall or how low down the wave is. It's how far it is from that resting position.
Resting position being that center
The
line.
x-axis.
I was about to ask what the resting
being
position was.
this
Resting
right here.
position is that center line upon which we draw either above or below the parts of the
Okay.
waves. And remember, one part above, one part below, or maybe one part below, one part above. That's one complete wave. How far off of that resting position, so from that center line up or that center line down, that's the amplitude. That's the height of the wave.
So if we're applying this to water waves, and Mr. Harkins is out surfing,
I don't
Do
do,
you-
anything
do you-
less than 20 foot.
yeah, 20 feet of amplitude. So that means
Yes.
a large wave has a large what?
Amplitude. So the
Amplitude,
bigger waves
okay.
have a bigger amplitude.
So the
Yep.
the pro surfers go for the high amplitude
Oh,
waves.
Brian have to be like, he's like 20 feet at least. Mine are more like 20 millimeters. Like,
Yeah.
I get rest.
So yeah, that's, I guess I could have clicked that up. But all right, so yeah, amplitude is distance from resting point to top or the bottom. Now, that top or the bottom, we're now going to put some technical terms to them. The highest point on a wave, which is at the top, is called the crest. Now, I've labeled two of them. There are actually three crests on this
Yep.
picture.
It's the high point.
The trough is the lowest point. Now, a trough is like what an animal
Yeah,
eats
like
out
a
of.
piggy.
like a horse
Okay.
trough or a pig trough.
Big
So,
piece.
and that's what it kind of looks like. It kind of comes down like that. You can't really put stuff in the drawing, but you know.
No,
Right.
but
The
you can
trough.
imagine.
That's why it's called that though, because it
Pretend.
curves
It's
downwards.
like the
this.
valley part there.
Mm-hmm.
Sweet.
All right, this is all you.
Oh, I don't know. This is tough. All right, so there's this thing called frequency within waves. And one of the things that you have to use to measure that is this thing called a period. And the period is the time required for one full wavelength. And
So
ideally,
you're saying you're actually timing waves sometimes?
yes.
Mm-hmm.
You take. What do you measure?
Well, you're measuring how long it takes for that wave to, the energy, the disturbance, to pass from one
Okay.
point or past a specific point.
Okay.
So you need what's called a point of reference for it. So in order to actually have a measurement of time, you've got to have a spot that you pick. Typically, there's a device that you use, and you just mark there's a line, and it's called an oscilloscope, and it just waves past it, and you measure from how long it goes from there and how many times the waves passed.
In a certain amount of
Right.
time.
The
Okay.
more waves that pass in a certain amount of time,
the higher the frequency,
higher
right?
the frequency,
Wait, we
which
got-
the lower the period.
Yeah. So
And
if it takes a
then-
longer time for one wave to go? Is that a longer period or a shorter period?
Shorter period. Shorter period gives you a high frequency. Long period gives you a low frequency.
Yeah. So
Okay.
and frequency, as we've been talking about, is the number of waves in a given time. So if you have a lot of waves in a short period of time, it's high frequency. If it's
Okay.
only like one wave in a period of time, so it's very few,
Right.
we call that a low frequency. Now think of it like this. If you've ever been to this is going to fall flat for some people, but if you've ever been to a wave pool before, like
Oh,
at Noah's
yeah.
Ark up in
Mine
Wisconsin
too.
Dells, yeah,
Yeah.
it's been a long time for me, but
Well,
there's a
especially
point
him,
where
he's,
they do
champion.
one wave like every minute. At that point, it's low frequency. You only go up like once in a
Okay.
minute. But then later on, they increase the amount of waves, and you start going up and down and up and down and up and down. You have more waves per minute or whatever.
Yeah, per
second,
time period. So
And
more
and
waves per
then
then
time.
it's higher frequency.
What do
Yeah.
we measure that in?
You measure
Hertz.
it in hertz.
Ooh, like, hey, want a Hertz donut?
No, what's a Hertz donut?
Hertz donut? Yeah. That's
Hilarious.
awesome.
Anyway, so there's a little math involved here, actually, and it's really easy math. It's just waves
Sorry,
divided by
okay.
time, so whatever unit of time. Waves per second is hertz, okay? So if you have 6 waves and it happens in 2 seconds, you just do 6 divided by 2, and you get 3
Three
hertz.
waves every second,
3
Okay?
Hertz.
which would be 3 Hertz.
Not the car company.
Mm-hmm.
All right.
So that is
Yeah.
actually it for this PowerPoint.
We're done.
Yeah.
See you guys in class.
Yep.
Bye.
Hang 10.